Hubble Space Telescope, humanity's window into the universe. A deep sleep documentary into one of history's greatest scientific achievements. Welcome to the Deep Sleep Channel. Tonight, we tell the story of one of humanity's greatest scientific instruments, a telescope that changed our understanding of the universe. A telescope that has been observing the cosmos for over 30 years. A telescope that has seen galaxies being born, black holes consuming matter, and the fundamental structure of existence itself. This is the story of the Hubble Space Telescope. It is a story of ambition and vision. It is a story of brilliant engineers and scientists working together. It is a story of failure and triumph. It is a story that teaches us about persistence, about the power of human ingenuity, and about our endless desire to understand the universe in which we live. Close your eyes. Let yourself travel into space. Let yourself float above Earth, looking down at the planet that sustains life. Let yourself drift upward, away from Earth, toward the realm of stars and galaxies. Let yourself journey with Hubble as it observes the universe. Let yourself contemplate the vastness of space and the smallness of our place within it. Let yourself drift into sleep, understanding that we are part of something incomprehensibly vast and beautiful. This is a meditation on discovery, on human achievement, on the beauty of the cosmos, and on our deep desire to understand our place in the universe. The dream, building a space telescope. The idea of a space telescope is not new. In the 1920s, scientists dreamed about placing a telescope in space, above Earth's atmosphere. The atmosphere distorts starlight, creating blurriness in images. A telescope in space would have a perfect view of the cosmos, unobstructed by atmospheric interference. But the technology to build a space telescope did not exist in the 1920s. A space telescope would need to be launched by a rocket. It would need to be placed in orbit around Earth. It would need to function in the vacuum of space, where there is no air, no water, extreme temperature variations, and deadly radiation from the sun. The challenge seemed insurmountable. But throughout the 20th century, scientists and engineers dreamed of this achievement. They imagined a great telescope orbiting Earth, looking out at the stars. In the 1960s and 1970s, as space technology advanced, the dream began to seem possible. NASA scientists proposed a large space telescope. Eventually, it would be named the Hubble Space Telescope, after Edwin Hubble, the astronomer who discovered that the universe was expanding far beyond our Milky Way galaxy. The design phase took years. Engineers had to figure out how to build a telescope that could function in the harsh environment of space. They had to make it small enough to fit in the space shuttle cargo bay, but large enough to make significant observations. They had to make it reliable, because it would be difficult to repair if something went wrong. The mirror of the telescope would be the heart of the instrument. The mirror had to be extremely precise. Any imperfection would distort the images. The mirror was made of ultra-low expansion glass, a special material that would maintain its shape despite temperature changes. The design was completed. Construction began. The project cost approximately $1.5 billion, an enormous sum in the 1980s. But scientists believed it would be worth the cost. A space telescope could revolutionize astronomy. The launch, April 24th, 1990. On April 24th, 1990, the Space Shuttle Discovery lifted off from Kennedy Space Center in Florida. In its cargo bay was the Hubble Space Telescope, packed carefully and protected. The shuttle climbed higher and higher, leaving Earth behind. After 2 days in orbit, the Space Shuttle reached the altitude where Hubble would be deployed. The cargo bay doors opened. Mechanical arms gently released the telescope into space. Hubble was now in orbit around Earth, beginning its mission to observe the universe. The telescope was placed in a low Earth orbit, approximately 380 miles above the planet's surface. At this altitude, Hubble would orbit Earth every 97 minutes. It would always have a clear view of space, except when it passed through Earth's shadow. Initial systems checks seemed promising. The telescope appeared to be functioning. Astronomers around the world waited eagerly for the first images from space. They expected to see stars and galaxies with unprecedented clarity. They expected to see details that had never been visible from Earth. Then, the first images arrived, and something was wrong. The images were blurry. They were not sharp. They were not any better than images from Earth-based telescopes. In fact, they were worse than expected. Something was preventing the telescope from focusing properly. Astronomers and engineers were confused and disappointed. The telescope had cost $1.5 billion. It had been launched, and it was not working as intended. Something was seriously wrong with Hubble. The crisis, a flawed mirror. Scientists immediately began investigating. What could be causing the blurriness? The most likely culprit was the primary mirror, the large mirror at the heart of the telescope. Careful analysis revealed the problem. The primary mirror had a flaw. It had a spherical aberration, meaning the mirror was not perfectly shaped. The outer edge of the mirror was grinding slightly too much. This tiny flaw, measured in microns, was causing light from distant stars to focus incorrectly. The starlight was spread out instead of being focused to a point. The flaw was minuscule, but in astronomy, tiny flaws have enormous consequences. The shape of the mirror was off by about 1/50th the thickness of a human hair. But this tiny error was rendering the telescope nearly useless. How had this happened? Investigations revealed that a measuring device used during the mirror's construction had been incorrectly configured. The error had gone undetected during manufacturing and testing. The flawed mirror had been installed in the telescope, and the flaw had not been discovered until after Hubble was in orbit. NASA and the scientific community faced a crisis. Hubble was the most expensive scientific instrument ever built, and it was broken. Some people argued that it should be abandoned. Some people thought the mission was a failure that could never be repaired, but others believed that Hubble could be fixed. The telescope had been designed with maintenance in mind. The space shuttle could reach Hubble. Astronauts could be sent to repair it. The challenge was enormous. No one had ever attempted to repair a telescope in space. The work would have to be done by astronauts wearing spacesuits, working in the vacuum of space, with only their hands and tools. The engineering required to fix Hubble seemed impossibly complex, but NASA decided to try. The solution: a corrective lens. NASA engineers worked frantically to design a solution. They could not replace the mirror in space. The mirror was too large, and the procedure would be too complex. Instead, they would install a corrective lens, similar to eyeglasses for a nearsighted person. The solution was elegant: a set of small mirrors, arranged like the lenses in eyeglasses, would be installed inside the telescope. These mirrors would intercept the light coming from the primary mirror and correct the aberration before the light reached the science instruments. The correction would not be perfect, but it would restore Hubble to near its design specifications. NASA built the corrective optics package, called COSTAR, Corrective Optics Space Telescope Axial Replacement. The device was roughly the size of a baby grand piano. It had to be installed inside the telescope, in a confined space, where there was barely room to work. The astronauts who would perform the repair mission trained extensively. They practiced the procedure underwater, in a large pool that simulated the weightlessness of space. They went over the steps repeatedly. They had to be perfect. If something went wrong, Hubble would remain broken. The repair mission, December 1993. In December 1993, 3 years after Hubble's launch, the Space Shuttle Endeavour lifted off with a crew of 7 astronauts. The mission was called STS-61. Its goal was to repair Hubble. The astronauts included 2 spacewalkers, Catherine Thornton and Story Musgrave, who would perform the repairs outside the shuttle. They were supported by 2 other astronauts inside the shuttle, who would manipulate the robotic arm. The shuttle reached Hubble and carefully approached the telescope. The robotic arm reached out and grasped Hubble, holding it steady. Now the real work could begin. Thornton and Musgrave donned their spacesuits. They exited the shuttle into the vacuum of space. Below them, Earth curved along the horizon. Around them was the vast emptiness of space. Ahead of them was Hubble, the telescope they had come to repair. The work was painstaking. The astronauts had to remove panels from the telescope. They had to carefully extract old instruments. They had to install the COSTAR corrective optics package. Each step had to be done carefully, methodically. One mistake could damage the telescope further. The work took place over 5 days. Multiple spacewalks were conducted. Thornton and Musgrave worked in their spacesuits, moving slowly and carefully in the vacuum of space. They were surrounded by the cosmos, by the stars and galaxies that Hubble would soon observe. Finally, the work was complete. The corrective optics package had been installed. The repairs had been finished. The astronauts returned to the shuttle. The shuttle released Hubble and began its return to Earth. The first clear images. January 1994. A few weeks after the repair mission, the first corrected images from Hubble were released. Scientists and the public held their breath, waiting to see if the repair had worked. The images were clear. They were sharp. They were beautiful. The repair had been a complete success. Suddenly, Hubble was seeing the universe with unprecedented clarity. Distant galaxies that had appeared as fuzzy blobs now had clear structure. Nebulae that had been indistinct were now detailed and beautiful. Stars that had been difficult to resolve were now sharp and clear. The scientific community erupted in celebration. Hubble was not broken anymore. It was working, and it was revealing the universe in ways that had never been possible before. The repair mission had been a triumph of human engineering and human courage. Astronauts had fixed a complicated instrument in the vacuum of space. Scientists and engineers had designed and implemented a solution that worked perfectly. Hubble had been given a second chance. The Hubble Deep Field, a window into the past. In 1995, astronomers decided to use Hubble to observe a tiny patch of sky. They chose an area so small that it would be invisible to the naked eye. It was only 1/50th the diameter of the Moon as seen from Earth. It was a region in the constellation Ursa Major, in what appeared to be an empty part of the sky. Hubble pointed at this tiny region and observed it for 10 days straight. The telescope collected light from this minuscule patch of sky. When the image was revealed, it shocked the world. In that tiny patch of sky, Hubble had detected approximately 10,000 galaxies. 10,000 galaxies in an area of sky so small that it would be invisible to the naked eye. Each galaxy contained billions of stars. Each star could potentially have planets around it. The Hubble Deep Field image showed that the universe was vastly more populated than anyone had imagined. If this tiny patch of sky contained 10,000 galaxies, then the entire universe must contain hundreds of billions of galaxies. The scale was almost incomprehensible. The image also showed galaxies of all ages. Some were nearby galaxies, seen as they are today, but many were very distant galaxies, seen as they were billions of years ago, when the universe was young. Hubble was seeing back in time. It was looking at the universe's history, written in light from distant galaxies. The Hubble Deep Field image became iconic. It appeared on magazine covers. It appeared in textbooks. It became a symbol of the vastness of the universe and humanity's ability to explore it. The most important discovery: accelerating expansion and dark energy. Throughout the 1990s, Hubble made numerous discoveries. Astronomers used Hubble to observe distant supernovae, the explosions of massive stars. They measured how far away these supernovae were. They measured their brightness. They could determine whether the universe's expansion was slowing down or speeding up. According to Einstein's theory of gravity, the universe's expansion should be slowing down due to gravity. All the matter in the universe should be pulling back on the expansion, slowing it over time. The expansion should be decelerating. But the observations from Hubble, combined with other observations, showed something unexpected. The universe's expansion was not slowing down, it was speeding up. The universe was expanding faster and faster, like a car accelerating rather than braking. This discovery was profound. If the universe was accelerating, something must be driving the acceleration. Some force must be pushing galaxies apart. Scientists called this mysterious force dark energy. Dark energy was discovered using Hubble observations. The discovery was so important that it won the 2011 Nobel Prize in Physics. Hubble had helped scientists discover that the universe is not what we thought it was. Dark energy makes up about 68% of the universe. Matter, including all stars, planets, and living things, makes up only about 5%. This discovery fundamentally changed our understanding of the universe. It raised new questions. What is dark energy? How does it work? These questions remain partially unanswered today. Other major discoveries, black holes, exoplanets, and star birth. Hubble has made countless discoveries beyond dark energy. The telescope has observed black holes at the centers of galaxies. By observing stars orbiting these black holes, astronomers confirm that supermassive black holes exist at the centers of most galaxies, including our own Milky Way. Hubble has observed the birth of stars. It has imaged nebulae where stars are being born, regions of gas and dust where gravity is pulling material together to form new stars. The images show this process in detail, revealing the structure of these stellar nurseries. Hubble has contributed to the discovery of exoplanets, planets orbiting stars other than the Sun. While Hubble does not directly image most exoplanets, it has made observations that helped confirm their existence and determine their properties. Hubble has observed supernovae throughout the universe. It has measured the expansion rate of the universe with unprecedented precision. It has observed the atmospheres of distant planets. It has contributed to almost every major astronomical discovery in the last 30 years. The technical marvel, how Hubble works. To fully appreciate Hubble, we must understand how it works. The telescope is a reflecting telescope, meaning it uses mirrors rather than lenses to focus light. The primary mirror is 2.4 meters in diameter, about the size of a large dining table. This mirror collects light from distant objects. The light bounces off the mirror and is directed to other instruments. Above the primary mirror is a secondary mirror. This smaller mirror intercepts the light and directs it to a hole in the primary mirror. Through this hole, the light reaches the science instruments. The science instruments include cameras and spectrographs. The cameras take pictures of distant objects. The spectrographs analyze the light from these objects, breaking it down into its component wavelengths. By analyzing the spectrum of light, astronomers can determine the composition, temperature, and motion of distant objects. Hubble can observe light in the ultraviolet, visible, and infrared wavelengths. Different instruments are sensitive to different wavelengths. The combination of instruments gives astronomers a powerful tool for studying the universe. The telescope is housed in a tube that is 13.3 meters long and 4.3 meters in diameter. The entire telescope weighs about 11,000 kilograms. It is powered by solar panels that convert sunlight into electricity. The telescope maintains its temperature despite the extreme conditions of space, with internal heaters and radiators. Hubble orbits Earth every 97 minutes. As it orbits, it can point at any region of the sky, except areas near the Sun or Moon, which would damage its instruments. Each year, Hubble can observe about 85% of the celestial sphere. The legacy, changing our understanding of the universe. Hubble has been observing the universe for more than 30 years. In that time, it has fundamentally changed our understanding of the cosmos. Before Hubble, astronomers were uncertain about many basic facts about the universe. The expansion rate of the universe was not well known. The age of the universe was estimated with large uncertainty. The prevalence of black holes was unclear. The abundance of planets stars was unknown, Hubble has provided precise measurements of these quantities. The telescope has shown that the universe is approximately 13.8 billion years old. It has shown that galaxies are common, with hundreds of billions of them in the observable universe. It has shown that the universe is expanding and accelerating. Hubble has produced some of the most iconic images in science. The Hubble Deep Field, the image of the Ring Nebula, the pillars of creation, images of star clusters and galaxies. These images have inspired millions of people. They have shown the beauty of the universe. Hubble has also been a triumph of human engineering and human determination. The telescope was not perfect when it was launched. It had a flaw, but humans designed a solution. Humans fixed the telescope in space. Humans have maintained it and upgraded it over 3 decades. The future, Hubble's legacy continues. Hubble is now in its 4th decade of operation. It continues to make observations and discoveries. The telescope is aging. Eventually, it will fail. But for now, it continues to look at the universe. Meanwhile, newer space telescopes have been launched. The James Webb Space Telescope, launched in 2021, observes the universe in infrared light, seeing even deeper into space and further back in time than Hubble. But Hubble continues its important work. It continues to observe nearby galaxies, nearby stars, and nearby nebulae. It provides observations that complement the observations of James Webb and other telescopes. Hubble's observations have transformed astronomy from a science that could only observe the nearby universe to a science that can explore the universe across billions of years of cosmic history. Hubble has shown us that we live in a universe far larger, far older, and far more complex than our ancestors could have imagined. A meditation on discovery and wonder. As we drift into sleep, contemplating Hubble and its observations, we contemplate what this telescope means for humanity. Hubble represents human curiosity. Humans wondered what was out there, beyond Earth, beyond the stars. Humans dreamed of building an instrument that could see the distant universe. And humans built it. Hubble represents human perseverance. The telescope was flawed. But instead of giving up, humans designed a solution. Humans risked their lives in space to fix it, and they succeeded. Hubble represents human achievement. The telescope has made discoveries that have changed our understanding of the universe. It has shown us the age of the universe. It has shown us the prevalence of galaxies. It has shown us that the universe is expanding and accelerating. Hubble represents human wonder. The images from Hubble are beautiful. They inspire awe. They remind us of the vastness of the universe and the smallness of our place within it. Looking at images from Hubble, we see the universe as it truly is. We see galaxies being born. We see stars being created. We see the vast cosmic landscape that surrounds us. We see the evidence of dark energy, the mysterious force that is expanding the universe. The cosmic perspective. The observations from Hubble give us what Carl Sagan's called the cosmic perspective. This is the realization that we live on a small planet, orbiting an ordinary star, in a galaxy among billions of galaxies, in a universe far larger and older than we ever imagined. This perspective can be humbling. It can make us realize how small we are in the context of the universe. but it can also be liberating. It can free us from the idea that we are the center of everything. It can help us understand our place in the cosmos. The cosmic perspective can inspire us to appreciate our planet. Earth is a beautiful place, full of life and diversity. It is unique as far as we know. We should cherish it and protect it. The cosmic perspective can inspire us to continue exploring and discovering. Hubble has shown us that the universe has many mysteries. There is so much we do not understand. The desire to understand drives human progress. Sleep and contemplation. As you drift deeper into sleep, let your mind contemplate the universe that Hubble observes. Think of the billions of galaxies, each containing billions of stars. Think of the distances so vast that light takes billions of years to reach us. Think of the time so deep that we are looking back toward the birth of the universe itself. Think of the engineers who designed Hubble. Think of the astronauts who risked their lives to repair it. Think of the scientists who analyze the observations and make discoveries. Think of all the human effort that goes into understanding the universe. Think of the images that Hubble has captured. The Hubble Deep Field, showing 10,000 galaxies in an invisible patch of sky. The pillars of creation, showing stars being born. The Ring Nebula, a dying star's final gift to the universe. Sleep, knowing that humans are capable of great things. Sleep knowing that we can build instruments that can see billions of light years away. Sleep knowing that we can understand the fundamental nature of the universe. Sleep, knowing that you are made of atoms that were created in stars. Sleep knowing that the calcium in your bones, the iron in your blood, the oxygen you breathe, all of these were created in the hearts of dying stars and scattered throughout the universe in supernovae explosions. You are made of stardust. Sleep, knowing that the universe is beautiful and vast and full of wonder. Sleep knowing that humans have the capacity to appreciate and understand this wonder. Sleep knowing that Hubble continues to observe the cosmos, revealing new secrets every day. Final words. Good night from the Deep Sleep Channel. Dream of distant galaxies and ancient light. Dream of the universe, revealing its secrets to patient observers. Dream of human achievement and human curiosity. Dream of the cosmos in all its beauty and complexity. Sleep well, knowing that above Earth, Hubble continues its mission. It continues to collect light from distant stars and galaxies. It continues to expand our understanding of the universe. It continues to inspire awe and wonder in all who see its images. Good night, sleep well, and dream of the stars.